Bismillahirrahmanirrahim. Assalamu alaikum. Recall, if our function is depending only on Brownian, then its differential by simplest Ito lemma is given by its first derivative with respect to Brownian times differential of Brownian plus 1/2 times second derivative of f with respect to Brownian dt. Right? So we will use this formula in the following setting of or the formation of a stochastic differential equation. Suppose there is a particle that is moving in the unit circle. uh, we have a particle that is moving in the unit circle and its position, let me call and define that by v sub t, which is given by two component x sub t and y sub t, and they are depending on Brownian as well. So x sub t is given by cos of w sub t and my y sub t is given by sine of w sub t. So my question or my target is to find out the stochastic differential equation for this v sub t. So v sub t is the column vector with component xy, which represent the position at time t of an object that is moving inside the circle with angle that is governed by Brownian motion. So the angle is basically governed by the Brownian motion. So my target is to find out what is my dv sub t. So of course it is equal to dx sub t or dy sub t, and this should be equal to d cos of w sub t and d sine of w sub t, of course. So you can now apply this formula that if my function is only depending on Brownian, then I can compute its differential by using this formula. So I need the first derivative of this function cosine, which is minus sine of w sub t, dw sub t, and then I need plus 1/2 and then its second derivative. So minus sine has the derivative minus cos of w sub t dt, right? On the same lines, I also need to compute the differential of the sine of w sub t. So first derivative of sine is going to be the cosine of w sub t dw sub t plus 1/2 times cosine has the derivative minus sine w sub t, of course, dt. Now what I can do more, I can write these differentials in another way. So like I can define a matrix with sine, so with cosine w sub t uh, and sine w sub t dt dw sub t plus 1/2. Okay, I need to write minus 1/2, right? Minus 1/2 times cosine of w sub t and sine w sub t and dt. So this is v sub t, basically this is also v sub t. Now I need the first component over here, which is minus sine. So I need a matrix. When I multiply its first row with this first column, I need minus sine of w sub t. So I will keep here 0 and minus 1. This could be one of the nicer choice. And then for the second row, I need cosine of w. That means when I multiply second row with first this column, I need cosine. So I need to keep 1 and 0 over here. So now I can call this is a matrix and this is v sub t. This is also v sub t. So my stochastic differential equation for this v sub t is given by 0, minus 1, 1, 0 times v sub t dw sub t minus 1/2 v sub t dt. So this is the stochastic differential equation that is satisfied by the v sub t, and my v sub t was the column vector with component x sub t and y sub t, which represented the position at time t of an object moving in the unit circle with angle governed by the Brownian motion. Thank you.